Okay, today's lesson is a summary of Lesson 3, Unit 1, Lesson 3, where you plugged and chugged a lot of points and then plotted those points. And so what this parent function packet is designed to do is basically help you summarize that information and get you familiar with, or hopefully our goal throughout the year is also to help you be able to see an equation and recognize its graph. So I'm going to go through our first set of graphs in our parent function packet that we have learned from this lesson. So the first one that we have is, let's look at this. We have f of x equals 2. And y'all remember that f of x is the same thing as y, so that is saying that y is equal to 2. And the key to this graph is it says it's constant because there's no variable over here and it doesn't change. Y is always 2, so I go up 2 tick marks and I'm going to draw my line. So it's going to go through like this. And that is the line y equals 2. And so what we have to do for each of these is state the domain and range. And remember, domain is not low. Make sure y'all paying attention. Domain is farthest to the left. What point is farthest to the left and farthest to the right? The range is what is the lowest point and the highest point. So when I look at this graph, furthest to the left, it has a left arrow, so farthest to the left is negative infinity. Farthest to the right, with the right arrow, is positive infinity. So that's our domain. Our range, the lowest point is, don't die on me, the lowest point is 2, and the highest point is 2, and is equal to 2, and always only 2, so we put brackets around that. Okay, the next one we have is linear, and the type of linear equation that you're familiar with, we talked about this a little bit since we've started school. You have y equals mx plus b, and y'all are able to tell me that m represents the slope and b is the y-intercept. But the form that we talked about most, a variation of this, was y equals m times x minus h plus k. Now y'all need to be familiar with both of these forms. Remember, m is still the slope, but this time, the thing that's nice about this form is we now know any point on the line, hk. hk is the point. Before, if we were using this form, I only knew the y-intercept, but this one, I can know any point on that. But to write my linear function, okay, so if you think about those, the y-intercept is 0, 0. That's where it's going to go through. And the slope is the coefficient. Actually, what do I want? I want this one. The slope is the coefficient of x, which in this case is 1. So we're going to have a slope of 1. So when you draw that, do your best to make it, put it in the middle of this quadrant, because we're going up 1 over 1. And that's how we get that slope. Now, what is the domain? Again, left arrow, negative infinity. Right arrow, positive infinity. And this time we do have a lowest point, and the lowest point goes on forever and ever down, so that's negative infinity. Highest point goes on forever and ever, that's positive infinity. Okay, so then I had the students look at their packets, because these two weren't really in our packets, but this next one, they graphed 6 graphs of that. And so they were able to tell me that whenever you see these lines around a variable, that it stands for absolute value, and this right here is telling you what it's going to look like. It's going to be a V. So when you graph that, okay, again, it's got that 0, 0 point. We'll go back to that. It's got a 0, 0 point here, and then when I go to the line, I'm going to do the same kind of thing, and that is try to get it in the middle of the quadrant. Okay, so this low point right here, we often call that the vertex, and in this parent function, it is 0, 0, and on our parent function, the slope is positive and negative 1, because that's the coefficient of my x right here. So domain and range, domain all the way to the left is negative infinity, got a left arrow. All the way to the right is positive infinity. Now, the lowest point here is 0. Can it equal 0? Absolutely it can, so we'll have a bracket and then parentheses, infinity, parentheses. All right, the next one we have was on that first page of your packet, and most of y'all remembered it from Algebra 1. And the quadratic equation is a parabola or a U-shaped curve. Okay, still has my 0, 0 point, and then do your best to make it look like a U. Okay, that 0, 0 point is again called our vertex, and it will be what changes with h and k, as you see. And I talked about these key points, and those are numbers that are easy to square, and we'll talk about this more when you graph, so that if you missed class, I wanted you to have this in your packet. And like I said, we will come back to it as we progress through the year. But the other side of this, 1 squared is 1, 2 squared is 4, 3 squared is 9. And we will use those points to make graphing quadratics much easier for you. Okay, domain and range. Farthest to the left, negative infinity. Farthest to the right has an arrow, positive infinity. Lowest point, 0. It does include that point. Highest point is positive infinity. Okay, moving on to our square root function. Okay, again, looking at your packet, if you looked at your graphs, okay, the original one starts here and does something of that sort. Kind of like a hook, some people call it different things. And it did occur to me, it kind of looks like part of that square root. So I'm just trying to get you to help you remember what these graphs are going to look like. Okay, it has that same 0, 0 point. And this time my key points, I'm going to pick numbers that are easy to find the square root of, which happen to be those right there. So I'm going to have 1, 4, 9. The square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. Again, we'll talk more about that when we get into graphing that. So, what is the domain? Farthest to the left, this time is 0. It does include 0. Farthest to the right is an arrow, so we go to infinity. Lowest point, again, is 0. This is kind of going up and over. So lowest point is 0, again, equal to 0. And the highest point is infinity. Okay? And the last one that we have on this page is our cubic graph. And again, has that 0, 0 point. So it's kind of a key point on each of these parent functions. Okay? And what did this graph look like? Remember, it's a curve, so do your best to make it look like a curve. You have 0, 0. My key points, negative 1, 1, and 2. When you cube negative 1, you get negative. Cube positive 1, you get positive 1. Cube 2, 2 times 2 is 4 times 2 is 8. So again, here's my graph. And the domain farthest to the left, negative infinity. Farthest to the right, positive infinity. Lowest point, negative infinity. Highest point, positive infinity. Okay, so those are 1, 2, 3, 4, 5, 6. 6 main graphs that you have and some key points, key information about them. We will refer to that a lot during the year. So the next thing that we did when we had those, and what you did in this last packet is you transformed them. That means you made changes to them, okay? And you did that by plugging in points and then plotting them, which is not always the most efficient way. So we're going to talk about how you can do that without having to plug in all those numbers. So to start off with, I want to remind you of your packet. And the first page of your packet, across the top, you graphed f of x was equal to x squared. And then you graphed f of x was equal to x squared plus 3. And then you graphed f of x was equal to x minus 2 squared. Okay, Now, as we fill in the chart, X is generally on the left side of this and Y is on the right. So I'm going to talk about those changes to the X and we'll put them here and changes to the Y over here. So we went back to the graph and I had them look at it and tell me what was the difference between this graph and that graph. And they told me this graph went up from that one. And then we looked at the original graph and this one, and they were able to tell me that this one moved to the right. So the next thing we discussed, and how you know that, is because there is a number. That's why it says number over here. There's a number in the equation that's not in here to begin with. And one of those numbers is inside the parentheses and one is outside. So outside, if you just looking at this, outside the parentheses, move the graph up. Which one of these variables moves the graph up? Well, I hope you all know that was Y. And so whenever you have that number outside the parentheses, then you know it's going to affect the Y value. If it's inside the parentheses, it's going to affect your X. Now, the other thing that we talked about was, if it says plus 3, does that go plus 3? If you're thinking on a y-axis, if you added 3, then you would go up. So what that looks like is exactly what we do. So it does the same thing. However, when you look at this here, which says minus 2, you look at x minus 2, you think you're moving to the left, but you're actually moving to the right. So whenever it deals inside the parentheses, it's always the opposite of what it looks like. Okay? Remember that x describes that horizontal motion on the graph. Y represents the vertical motion. And the variable that you often see representing that horizontal motion is h. And the variable that you're going to see representing the vertical motion is k. So whenever you see that, you're going to know that h is moving it left and right. K is moving it up and down. Okay? So then the next set of graphs on that page from lesson 3 was f of x equals negative x squared and f of x equals negative x parentheses squared, and then we had f of x equals 3x squared. Okay, so looking at these first two, what's in there? We don't have a number, but what we do have that we always have to treat separately is the negative sign. So when you have a negative in there, and so again, we looked at the first graph and looked at this graph, and how are they different? Well, the negative is outside, so we know it's going to affect the y. What did it do to my graph? It flipped the graph over the x-axis. This one, of course, was inside. It's going to affect the x, and it flips over the y-axis. Now, a lot of people get this confused, but let me just remind you. Looking at this one, the negative is outside. Outside affects the y. It affects the y, so that's why it flips it over the x-axis. Because if you were to think of a coordinate plane, and you had a y value right here, okay, and you made that value negative, then that would go down here, which is flipping it over the x-axis. So if it affects the y, it flips over the x. If it affects the x, it's going to flip it over the y. Okay. Now the last thing that we talked about was the operation. How many different operations do we have in math? Hope you all answered 4. And 2 of those operations describe a shift, and the other 2 describe a stretch or a compression. So we looked up, and how do we know when it's going to shift? Left, right, up, and down. Well, when you look back at our equations up here, you can see that it's if we are adding or subtracting to an equation, then we have a shift, which means that if we're multiplying or dividing to an equation, we have a compression. Okay, so then we went back and looked at f of x equals 3x squared, and on that particular graph, they were able to tell me that it was skinnier. Okay, And therefore, so this is again the same thing. It's outside the parentheses. And somebody asked me what it would look like if it was inside. I will tell you it would look like this. It would say f of x is equal to 3x squared. So that means you're multiplying by 3 before you're doing the exponent. And up here, we're doing the exponent, and then we multiply by 3. So what that did to our graph is it ended up making it tall and skinny, which is kind of what we call a vertical stretch. Okay, it's outside, it's affecting the y, it's a stretch, and this number in the front being multiplied by anything is always referred to as that a value. So vertically, if a is larger than 1, we have a stretch, and if a is less than 1, we have a compression. Okay, this is for vertical. Okay, because vertical does the same thing. So if horizontal, we would do the opposite. So if it was horizontal and a was a was greater than 1, you would have a compression. And if a is less than 1, you would have a stretch, because you always do the opposite. Okay, so if you're good to go, you can go. But if you want to, I did a few examples that you're going to see later on as we finish up this unit, half of the unit anyway. So I just wanted to do a few so that if you wanted some help and you could listen to them. So this first one here, let's go with write the equation of the function y equals x squared after it is shifted left. Okay, shifted left is going to affect my x, and shifted down 5 is going to affect my y. So if it affects the x, it's on the inside. So I actually have to add parentheses to this to make my left x. And remember, left you think is minus, but we do the opposite. So that's x plus 3. And then the y, it does exactly what it says. It says the same thing. So my function is y equals x plus 3 quantity squared minus 5. All right. And feel free, if you feel comfortable with this, would be a really good thing for you to pause the video and then unpause it and check your answers with what I've got. Write the equation of the function y equals the square root of x after it is flipped over the y-axis. So if it flipped over the y-axis, it's affecting the x, which means it's going to be on the inside. So I'm going to go put it on the inside. Shifted 7 units up. Up is affecting the y. Does the same thing, and a shift is adding or subtracting. So plus 7. All right, let's look at this next one. Write the equation of the function y equals the absolute value of x after it is vertically stretched by 4. Should have said a factor of 4. Y equals a vertical stretch is outside. Oh, and shifted right. So that right, okay? This vertical stretch is the y, but shifted to the right is the x. So I have to go back in here, and to the right, it does the opposite of what it looks like. So that's what we're going to have. All right, let's look at the next one. Write the equation of the function y equals x cubed after it is shifted 2 units to the left. Left affecting is x. Vertically stretched by a factor of 3, that's the y. And flipped over the x-axis. Again, if it's flipping over the x, it affects the y. So let's see what we got here. Well, if I have an x, then that means I got to show something in this parentheses. And that's going to be x shifted 2 units to the left. Left is going to be plus 2. Vertically stretched by a factor of 3 means multiply by 3. And flipped over the x-axis is where we're going to have that negative. So that would be our answer. I probably should box these so you can tell amongst my other writings. Okay. Let's go with, I think, oh well, wrong one. Okay, and that way there won't be any question of what the answers are. Okay. Write the equation of the function y equals the absolute value of x after it is flipped over the x-axis. So are y'all telling me x-axis affects the y? Translated 3 units up affects the y. 6 units to the left affects the x. So y equals flipped over. When you flip something, you got a negative sign. If it's inside the parentheses, that's just inside that function. These symbols here for absolute value are grouping symbols just like parentheses are. So if I'm going 6 units to the left, that's going to be x plus 6, because we do the opposite of what it looks like, and translated 3 units up, plus 3. So 3 changes, there's my equation. All right, one last one. I don't want to go into that right now. It says, write the equation of the function y equals x cubed after it is flipped over the y-axis, so that's affecting the x. Translated 4 units down is affecting the y. Vertically compressed, again, affecting the y. So if I have something with the x, it's inside, so I've got to put these parentheses in here. Get a little more room. Now, it's flipped, so that just means the negative sign. And translated 4 units down is going to be my minus 4. Vertically compressed by a factor of 1/5 is there. Now, you do not have to simplify these. Right now, all I want you to do, I don't want to see minus a negative 6. But other than that, this is all that you have to do to write the equation of your function. All right, well, I hope that helped. Please come see me or email me if you have any questions.